If f is a continuous function on a to b and our function is greater than or equal to 0 on a to b, then the exact area between y equals f of x and the x-axis from x equals a to x equals b is given by the area is equal to the definite integral from a to b of f of x dx. So all that's saying is if you have a function here, here's a, here's b, and it's above the x-axis, and this is our function f of x, then if you were to find the area under the curve between a and b and between the function or the curve and the x-axis, that area there is given by the definite integral from a to b of f of x dx. So that is very helpful for us, and now that we have the fundamental theorem of calculus, that's also helpful. Example 6 says, find the area between the curve y equals negative x squared plus 3x minus 2 and the x-axis from x equals 1 to x equals 2. So we're just wanting to find the area is equal to the integral of our function dx, and so that's going to be negative x cubed over 3 plus 3x squared over 2 minus 2x evaluated from x equals 1 to x equals 2. So that's going to be negative 2 cubed plus 3 times 2 squared minus 2 times 2. Can't forget these denominators, and then minus, and it's important, you always want to put brackets because students will often forget to distribute that negative sign. Okay, so let's go ahead and simplify that. So we get negative 8/3 plus 6 minus 4 minus negative 1/3 plus 3/2 minus 2. Okay, and then we will get negative 8/3 plus 2 minus, I'm going to go ahead and distribute in that negative sign. So we'll get plus 1/3 minus 3/2 and then plus 2. And we're going to end up needing a common denominator. So I'm running out of space. Let's come up here. That's going to be negative 7/3 minus 3/2 plus 4. So I'm going to make all the denominators 6. So that's equal to negative 14 over 6 minus 9 over 6 plus 24 over 6, and then negative 14 minus 9 is negative 23, so our final answer should be 1 over 6. Example 7 says, suppose that money flows continuously into a slot machine at a casino and grows at a rate given by a prime of t equals 100 times e to the power of 0.1 t, where t is in time in hours and t ranges between 0 and 10. Find the total amount that accumulates in the machine during the 10-hour period if no money is paid out. So the amount of money given after between 0 and 10 hours is represented by the integral from 0 to 10 of our function 100 times e to the 0.1 t dt. I'm going to pull out the 100. And I'm going to make u equal 0.1 t. And then du is going to equal 0.1 dt. And then if I divide both sides by 0.1, we find that dt is equal to du over 0.1. And so now we have 100 divided by 0.1 times the integral from question mark to question mark of e to the u du. And that equals 1,000 e to the u evaluated from u equals question mark to u equals question mark, and then I'm going to sub back in the u value, so we'll have 1000 e to the 0.1 t, and then evaluate from t equals 0 to t equals 10. So that's going to be equal to 1000 e to the 0.1 times 10 is 1, minus 1000 e to the 0.1 times 0 is 0, and that's going to end up equaling just 1000 e minus 1000, which is approximately $1,718.28. So that is how much will have accumulated in the slot machine after those 10 hours.